Да.
Да, здравствуйте.
Отлично, здравствуйте. Так, пока собираются, еще пару минут подождем и начнем. Давайте потихоньку начинать. Я прошу прощения, что в расписании не оказалось пас-кода. Я разместила в ЛМС. И еще что-то у нас творится с расписанием. Я, например, в пятницу видела, что пары у нас начинаются с 13 часов, а сегодня обнаружилось, что в 11:10. Возможно, не все записанные студенты об этом знают, поэтому я надеюсь, что тем не менее ЛМС доставляет информацию, по крайней мере, то, что я вывешиваю в качестве объявления. Итак, у вас есть конфа VK. Замечательно. Так, я начну по-русски, потом... Я правильно понимаю, что все понимают по-русски и... Да, судя по фамилиям и именам, для вас не будет проблемы и русский, и английский. Всю информацию я буду выкладывать в ЛМС и также делать рассылку в виде объявлений. Если нужно что-то срочно получить, информация вам должна доставиться на ваши корпоративные адреса. Дополнительные ссылки тоже будут в ЛМС, и материалы тоже буду вывешивать в ЛМС. То есть я предпочитаю, чтобы все было на одной платформе, чтобы не приходилось скакать то на Google диске, то в Яндекс, то еще куда-то. Меня зовут Иванова Вера Ивановна, я доцент департамента экономики Санкт-Петербургской школы экономики и менеджмента, департамент экономики, кандидат физико-математических наук, и я также научный сотрудник Центра теории рынков и пространственной экономики. Насколько я понимаю, вы из разных департаментов, даже из разных кампусов, насколько я могу судить из ЛМС. И курсы у вас также разные, от 2 до 4 включительно. Что вас ожидает? Курс я изначально планировала в основном практический, с использованием геоинформационных систем в компьютерных классах. Для меня было большой неожиданностью, что я вообще не имею права проводить в компьютерных классах даже часть занятий, поскольку это дисциплина по выбору, а все дисциплины по выбору должны проводиться онлайн. Поэтому прошу прощения, приходится адаптироваться к существующим ограничениям. Так, уважаемые студенты, я буду очень рада, если вы хотя бы на время можете включить камеры, потому что это довольно утомительно преподавать черным прямоугольником. К тому же вы сами можете и друг друга увидеть. Замечательно. Спасибо тем, кто включил камеры. Okay, I think it's time to start our first lecture. Let me share my screen. Can you see my screen?
Yes.
Thank you. The first lecture is introductory lecture. What is geospatial analysis in economics? And the outline of my today's talk is as follows. The outline of course, what to expect, what you are going to learn, and basics of GIS. For what? The main thing to ask. The so-called intending and learning outcomes are as follows. I can see something in okay. Intending learning outcomes. You will know basic modern geographic information system tools to visualize, process, and analyze spatial data in economic problems. And also, you will learn main spatial econometric models, and you will be able to estimate and interpret them. And also, I think the main is that you will be proud of yourself that you can use GIS systems to visualize beautiful maps, and also you will be able to do geographic analysis. Also, you can easily handle different shape files. You can become an expert in satellite images to process, and so on. So we have 15 classes, 8 lecture and 7 seminars with computer exercises. And the final grade consists of grades for in-class tests, as well as homework, and the final exam will be in the form of an oral defense of written essay. This will be an applied research project. The research project can be made can be a group project up to 3 people. You will get details later. What is geospatial analysis? Let's start from this. Geospatial analysis, or just spatial analysis, is an approach to statistical analysis and other analytical techniques to data which has a geographical or spatial aspect. So we know that such analysis, even just a statistical analysis without cannot be performed nowadays without any computers. So we'll employ spatial software to process spatial data. Also, it's not enough only to visualize maps. We will apply analytical methods to geographical data sets. Let's jump to examples for spatial data sets in economic problems. You can see 2 maps of the Great Britain regions. The source is by Duranton and Overman, testing for localization using microgeographic data, the real economic studies. 2005. You can see the location patterns of 2 industries, basic pharmaceuticals, locations of plants of basic pharmaceuticals, we can see that the main cloud of the main cluster is located in this region. For the second picture, as for the second map, pharmaceutical preparations, the cluster is not very clear. We can see that plants are more dispersed across the country. And a couple of more maps. Our agriculture and forestry machinery industry. The plants of this industry are dispersed almost randomly across the country. And the last map from this paper corresponds to plants of machinery for textile, apparel, and leather production. And the cloud or the cluster maps is located in the middle of the country. So we can see that allocation patterns for different industries are very different. And visually, we can say that here we can see a cluster, here we can see a dispersed pattern for plant locations. And there is a question how to measure whether this pattern is dispersed, whether this pattern is specialized or clustered. So these problems can be solved using statistical methods and for spatial data sets. One more example for using spatial data in economic problems is the next one, commuting flows. The source for these three maps is a paper by Patacchini and Zenu, Spatial Dependence in Local Unemployment Rates, Journal of Economic Geography. We can see commuting flows for different years, 1981, 1991, and 2001 census data. We can see that changes are present, but they are not very significant, almost at least from these three pictures. We can see white regions with low commuting flows. We can see black regions with high commuting flows. Here. Also, we can have a look at unemployment rates. Low unemployment rates usually corresponds to those regions where we can see high commuting flows. And discussing these maps, and when discussing these maps, we cannot say that colors are randomly distributed. That is, unemployment rates and commuting flows are not randomly distributed. Also, we can say that black regions usually are surrounded with dark regions, and white regions usually surrounded with light regions. So we can say that similar patterns similar patterns tends to similar colors. Let's have a look at another map. I think you could see many different maps with COVID-19 cases.
Excuse me. On that map, what is the idea of the division of the space? So, what is
Unit of observation or
no, what is situated in one particular cell? So,
counties, not states, but counties,
okay, thank you.
like municipalities or raions in Russia. Here we can see the US map. Cases of COVID-19 per 100,000 residents in the USA by county. Areas with no available data are colored gray. The darker, the higher COVID-19 cases. What can we see from this map? The darker areas corresponds to main hubs for airports, for international airports. The map corresponds to the beginning of the pandemic. Not the very beginning, but 3 or 4 months later. So the distribution of COVID-19 cases started from main international airports. The next example. This is St. Petersburg and surrounding regions climate data. Also, we can see that rains are not randomly distributed. And this can be used, for example, for agricultural problems. Also, climate data with precipitation data, осадки. Green corresponds than these areas, and a blue area, blue dots with a bit higher precipitation, and so on. We can see that observed precipitation is also not random variable. Soil quality. This is a map of the Russian Federation. Soil quality by types is indicated by different colors. Криозем, глинозем, чернозем, and many different terms from soil terminology. When a new fertilizer is invented, новое удобрение внедряется, и для того, чтобы проверить эффективность, вносят различные дозы удобрения на различные участки. Разные участки с разным составом почвы могут дать разные урожаи, однако если они близко расположены, эти участки, то их почвенный состав практически одинаковый. И они не должны влиять на применение точного сельского хозяйства. Простите, я не знаю точного перевода на русский. Precision agriculture будет давать результаты для сравнительного анализа эффективности удобрений. The next example is air pollution. The most polluted country is China. Here you can see a real-time air quality index visual map. Качество воздуха, уровень загрязнений воздуха в реальном режиме. Есть такая карта Air Quality Index. That the most polluted located in this. Usually, such areas correspond to high machinery or most polluted manufacturing industries. Here we can see the notes on air quality index. Air pollution level is good when on the map you can see green dot. Moderate air pollution level is yellow, then orange, and unhealthy level is red, and very unhealthy and hazardous darker. So darker regions are here, and the most dense manufacturing industries located in here, in this part of China.
Excuse me. And the point on the previous map, which is marked with 999 points, is it a mistake or what is it?
This map?
Yes. Here. Is it a volcano or what?
I have zero information about these outliers. Sorry. Probably this is an outlier or measurement error, or maybe something. Maybe this is a location of a plant where they do not use any anti-pollution technologies. This may happen.
Okay, thank you.
Another part of this map is European part. We can see that the pollution level is good. Almost no red regions. And by the way, zero. This side doesn't provide any information about Russia. Probably the reason is that not all the countries provide real-time pollution index to that site. I wish I could know about Russian industries as well. Okay. Another example of spatial data is crime level data. Here you can see New York City map, Manhattan, Brooklyn, Queens, the Bronx, and Staten Island. Murders in New York City. Race or ethnicity of victim is indicated on this map. Homicides from 2003 to 2011 are indicated on this map. We can see that black victims share is 61%, and they mainly located in Brooklyn, in Queens, and in this part of the Bronx. The second main race of victim is Hispanic. Oh, air quality map. Okay, thanks. And Hispanic victims are observed in Brooklyn and Queens and in Bronx mainly. White victims were located in Manhattan and in this part of Brooklyn. So we can see that locations of victims are very different, and spatial location patterns probably depend on the population distribution in the city. Let's have a look at the map by this link, Brizometer, air quality, Russia. Just a second. I have a question. Can we compare this index with the previous index, for example, in China or in Europe? My internet connection probably is very slow, so I can see for now only Moscow. I cannot move the map.
I think to some extent at least, yes.
At least we can compare colors, like green, red.
Так, мне надо что-то остановить, потому что я перестала видеть экран зума. Так. Sorry, I cannot share because of, I think, because of the slow internet. I will take a screenshot for the next class and include it to the presentation. Thank you for the link. Another example of spatial data is house prices. We all know that house prices depend on characteristics of the house, that is the area, the number of bedrooms, bathrooms, the level, the amenities inside the building, and so on. Depend on location, and prices of houses or apartments in the same neighborhoods are very similar, given that their other characteristics are. Here you can see house prices in St. Petersburg 2 years ago. Green areas correspond to cheap apartments, and red areas correspond to expensive apartments. This part, that is Petrogradsky district, is usually expensive part of St. Petersburg, as well as the central part of the city. The new areas of St. Petersburg are usually in green. So we see that expensive areas are surrounded with expensive areas. That is, black is surrounded with red areas, and green is surrounded with green or yellow areas. Another example is real wages.
Excuse me.
Okay.
Can we somehow use this data? Can we build some sort of system or see some links between the numbers? So, does the picture mean anything to us besides the price? So, how is that picture made so we can understand the links? So, is there some math beside those processes? So, because it may be the sixth or the seventh picture of geospatial data, but can we extract something from them?
Okay, why we expect similar prices?
We can't hear you now.
Can you hear me?
Now, yes. Sometimes
Okay.
your internet connection is not so good, and we can't hear you.
Let me close some windows. Okay. Okay, let's have a look at this part of the city, close to Дворцовая набережная. Okay, we understand that this part of the city is the so-called historical part of the city. And the buildings are rather old. Their ages are at least a couple of centuries. So there are spacious rooms and high. Beside this, all these buildings are located to amenities, close to spatial things that are similar to all these buildings in this area. They're close to touristic amenities. They're close to beauty. They're close to Nevsky Prospect and so on. So besides the common things to all buildings, they also share common spatial amenities in surroundings. As for this region, part of St. Petersburg with new buildings, they also have similar houses, new buildings with large areas or playground made of new materials, no problems as in old buildings with old problems. Also, the new buildings may have car parkings, may have new large schools, new amenities inside each big building. Beside this, are located close to big parks, close to different green zones, forests, and so on, or maybe lakes, and so on. That is, they share common amenities, or maybe amenities, maybe disadvantages because of being close to manufacturing plants, being close to different spatial things surrounding these buildings. So behind this map, the story is as follows. Not only building characteristics construct or made house prices, but amenities and surroundings.
However, the buildings outside the city center are usually cheaper.
Yeah.
They can be new.
Access to transportation system. I forgot to tell about this.
Okay.
Yeah. Yeah. And access to transportation system, and more important, access to metro. Okay. Another example is commodity prices. Цены на товары. Here you can see a historical map of the Russian Empire as of 1897. Here you can see the spatial distribution of price of rye, цены на рожь, на зерно. The average rye prices in 1897. копеек за пуд за 16 килограммов. Green dots corresponds to cheap rye in governorates в губерниях, and red dots corresponds to high prices. The spatial pattern for this map is as follows. Provinces or governorates that do not have good access to foreign markets, that is Volga region, and close to Ural mountains, and those regions that have good soil quality and good climate for rye crop, they have low prices. And those provinces where the soil quality and more especially climate was not favorable for agricultural works. Here you can see high prices for rye. That is St. Petersburg, Baltic regions, Baltic provinces, and so on. Here in Odessa, close to Odessa and Crimea, you can see low or moderate prices, although this part of the country had access to foreign ports across the Black Sea. But this part of the country was with good conditions and good conditions for agriculture, and the soil quality was rather good. Here you can see.
Excuse me. So from that map, we can see a correlation between prices and soil and maybe trade routes, something like that.
Yeah.
Okay.
Yeah. Here you cannot see any trade routes except those lines, except the rivers, I would say. Yeah, I think there are no railroads in this map, but they are also significant. And importantly, here you can see the so-called spatial autocorrelation. Prices in each location were very close to prices in neighboring locations. That is, we can see spatial autocorrelation. Later you can learn a bit more about spatial autocorrelation, and you will compute spatial autocorrelation indexes. Let's jump to...
there can't be a situation when we have rather high prices and near them very low prices. So this situation is very rare.
Usually, yes. The situation is very rare. Usually, you observe similar prices, similar values of a spatial variable in neighboring regions. And when you consider
We can't.
variable, you cannot permutate the values. When you estimate usual econometric models, you can draw a scatter plot without any spatial ties, without any location information. But here, you cannot mix the dots. All they are located exactly there where the data were derived.
Okay, thank you.
The next map, let's jump to the Russian Federation. Real wages in Russia. Real wages computed as market baskets in cities. For each city or town, the average monthly wage was divided by the price of the market basket. And here you can see the dots. Almost 1,000 dots, almost 1,000 cities and towns in Russia. The higher the size, the higher the city wage. We can see many high wages in Moscow and the Moscow region, and many high wages in St. Petersburg and surrounding regions. And also, I would say we can see the route of money between Moscow and St. Petersburg cities. Also, we can see the zone of high wages in Arctic zone, the so-called, sorry, not Arctic zone, the far north, or the territories equated to the far north, территории крайнего севера и приравненные к ним территории, если я не ошибаюсь по-русски. And we can see many poor Russian cities and towns. They are located in the Volga region, and they are rather far from Moscow. Usually, the poor cities, the poor towns are rather small towns, and most of them are single industry towns. The next example is a spatial distribution of malaria in 2010. Here we can see the darkest part of the darkest part of Africa. This corresponds to the higher level of malaria cases, and 0 cases in some continents, for example, in Europe, in Asia, 0 cases in Europe, in Australia, and in the North America. And it's obvious that the spread of disease is spatially dependent.
Maybe it is linked with the location. So, is it hot enough for insects to live or not?
Maybe it's the reason. It's one of the reasons. Also, when we consider the disease, we can think of trade routes. We can think of connections of people and traditions. Are located in one time zone and one climate zone. Although in this part of Australia, for example, we can see 0 cases of malaria. And I think this is the last example of spatial data. Информация по эпизоотической обстановке на территории Забайкальского края и Амурской области. Here we can see cases of leucos and cases of brucellose. This hardly depends. It depends on proximity of agricultural enterprises. Близко расположенные сельскохозяйственные предприятия, которые, возможно, между собой торгуют или там племенные хозяйства продают скот в другие близко расположенные хозяйства, и тем самым происходит распространение заболеваний. Okay, I think you can find many different examples of spatial data, and you can face many different spatial patterning in economic problems and not only economic problems. A key insight is that observations in space cannot be assumed to be independent mutually. They are dependent. They depend on each other. They depend on neighbors. And that is, observations that are close to each other are likely to be similar. This spatial patterning, or we can call this spatial autocorrelation, may be treated as useful information about unobserved influences. But it does challenge the application of methods of statistical inference that assume the mutual independence of observations. When you study econometrics, I think you remember that observations are independent. In spatial econometrics, they are not. Spatial data analysis is concerned with questions not directly answered by looking at the data themselves, but it's important. These questions refer to hypothetical processes that generate the observed data. Statistical inference for such spatial processes is often challenging, but is necessary when we try to draw conclusions about questions that interest us. So visualization is an important thing to start with, but this is not enough. We will study a GIS system. More precisely, we will learn how to work with QGIS. And what is GIS? A geographic information system is a system that creates, manages, analyzes, and maps all types of data. GIS connects data to a map, integrating location data with all types of descriptive information. There are many different GIS software. The most important, okay, not important, but most famous ArcGIS. This is not a free source. The software is rather expensive. The second one, QGIS, we're going to learn how to work with this, is a free software, also MapInfo, GRASS, and so on. You can have a look at the list of geographic information system. Sorry. Just a second. You can find this link in the chat, list of geographic information systems. There are plenty of them. To start with spatial data, you need to know about coordinate reference systems. Unlike the common table data, spatial data have spatial reference. They have coordinate values and a system of reference for these coordinates. Data is defined in horizontal and vertical coordinate systems. Horizontal coordinate systems locate data across the surface of Earth, that is longitude, долгота, широта. Vertical coordinate systems locate the relative height or depth of data, то есть высота, например, над уровнем моря и глубина, то есть вверх или вниз. Usually we consider horizontal coordinate systems. They can be of three types: geographic, projected, or local. Geographic coordinate system typically has units in decimal degrees, measuring degrees of longitude, долгота, x координата, and degrees of latitude, широта, y координата. The location of data is expressed as positive or negative numbers. Positive X and Y values for north of equator and east of the prime meridian, and negative values for south of equator and west of the prime meridian. You can have a look at, just a second. You can have a look at this page in Wikipedia. Please find the link in the chat. You can see that there are spatial coordinates in degree and in decimal degrees.
Where should we look to find this information?
On the right panel.
Right panel.
With the right panel in Wikipedia, with a brief information about the city. Just a sec, let me check this.
I can see only coordinates and a red area where the St. Petersburg is actually situated.
Can you see degrees or decimal degrees?
Do you mean coordinates or not?
Yeah.
Yes,
Yeah.
I can see them. Yep.
When you studied geography in high school, you usually used degrees, minutes, and seconds. But in GIS systems, we will use decimal degrees. This is easier to handle, to process, and to store data. Okay, geographic coordinate systems usually use longitude and latitude data. Local coordinate system. Some data may be expressed in a local coordinate system with a false origin. No connection to 0 degrees or 0 latitude, 0 longitude. Just we can say that let's define that St. Petersburg will be our false origin and a starting point. Local coordinate systems are often used for large scale, that is, small area mapping. So if we are going to consider only St. Petersburg area, and we can assume that the globe is planar, then we can use our own coordinate system. Usually, local coordinate systems used in small area mapping and exercises. The false origin may or may not be aligned to a known real-world coordinate, but for the purpose of data capture, bearing and distances can be measured using the local coordinate system rather than global coordinates. When it's not significant global coordinates, we can just drop the information about this. When we define a false origin, we can use a term datum. Datum is a set of reference points of the Earth's surface against which position measurements are made, and an associated model of the shape of Earth to define a geographic coordinate system. And the third type of coordinate, sorry.
Could you please one more time explain what is it, datum?
Datum, datum,
We can't hear you now.
the false origin 00 set of reference points in geographic coordinate system. X0, Y0 is the datum.
Mhm.
We can have a look at this in the next slide. Projected coordinate system. Spatial data usually is expressed, especially in GIS systems, especially in during visualization. We use projected coordinate system. Here you can see the globe. The globe is not planar. We need to have a picture on a flat place. You can see that this point is indicated in here. This point has a longitude and latitude in degrees, but when we this and defined coordinates in meters, we can see that all the coordinates, instead of so we can consider as a planar coordinate system in metric system. Also, here we defined the starting point as 0 degree latitude and 0 longitude, and this will be our datum. Let's have a look at this example from the textbook by Bivand. We have a list of coordinates for some data set of volcanoes as pairs of longitude and latitude in decimal degree values. With respect
Excuse
to
me.
the prime, yeah.
Unfortunately, you continue to disappear from time to time, and sometimes it is not crucial for understanding, but sometimes the half of the sentence is missed, and it's rather hard to understand the idea.
Thanks for telling me. I had no idea that the problem is so crucial. Let me check whether I can maybe lower the quality of the video. The settings, maybe. No. No, this is not high definition. Just the original ratio. I think right now I cannot do anything about this. For the next hour class, I will try to fix the problem.
Okay, thank you.
Let's continue. One more example about coordinate systems. Volcanoes a data set of volcanoes, a data set of coordinates, longitudes and latitudes with respect to the prime meridian at Greenwich and zero latitude at the equator. The World Geodetic System, or shortly WGS 84, is a frequently used representation of the Earth. This one. 0 and 0. So the datum is the starting point, zeros. Here you can see locations of volcanoes of the world. They are in blue. The data set consists of points only. When we want to draw these points on a flat map, we are faced with the problem of projection. We have to translate from the spherical longitude-latitude system to a new non-spherical, which inevitably changes their relative positions. So we can compare this map with the previous picture, and the lower part is very different, and it looks as if this is the largest area in the world, but this is not. So we can define many different projections. And if you are interested in many different coordinate reference systems, so you should know that there are thousands of them. For example, in QGIS, there are almost 3,000 known coordinate reference systems. And you can define your own coordinate system. Also, you can define your own projections. The idea of making a projection of a map is rather simple. You can consider cylindrical projections, that is correspondence the second type of projection is conical projections. You take a cone, you take the globe, and you get this type of projection. And planar projections is a type of C. So the idea is very simple. I think you understand that map projections are never absolutely accurate representation of the spherical Earth. Never. You have to face distortions of angular conformity, or distance, or area, or altogether. Искажения будут всегда. A map projection may combine several of these characteristics, or maybe a compromise that distorts all the properties of area, or distance and angular conformity with some acceptable limit. There is no ideal projection for the globe, for all all the areas simultaneously. Usually, when you focus on a country, when you focus on some region, you have to choose a proper projection only for this region. For another region, for another continent, maybe not good. You can see that you can see the recommended region for each projection. How much time do I have? Okay. I think it's time to have a break. Then we will continue. How long do you want to have a break? 10 minutes, 20 minutes, half an hour?
In our timetable, we have half an hour. Maybe we should stick to it.
Okay. Let's have a break, half an hour.
Okay, thank you.
Thank you. Так, попробую переключиться на другую камеру. Смотрим, возможно, так будет лучше идти. Окей. Меня видно, слышно?
Да, вас видно и слышно. Здравствуйте.
Здравствуйте, спасибо. Okay, let's continue. I'm sharing my screen. Let's consider types of spatial data in GIS systems. Point data or a single point location, such as a global positioning system data, is very often used in GIS. For example, your location as latitude and longitude is an example of point data. Line is a set of ordered points connected by straight line segments. For example, if you record your day in, for example, Google Maps, you'll get a set of points, a set of locations you visited today. A polygon, it's an area marked by one or more enclosing lines, possibly containing holes. For example, a shape of a building you are located in is an example of a polygon data. The first three spatial data models are vector data models. And they represent entities as exactly as possible. Also, GIS systems use image data or grid data. It's a collection of points or rectangular cells organized in a regular lattice. An example of this is a satellite a satellite image data, that is, for example, night view data, or satellite images of forest trees and so on. То есть спутниковые снимки, например. You can represent one object using very different spatial data models. For example, a volcano. We have a map with volcanoes as points, but here you can see lines in the largest part of the picture. Topographic information, that is altitude for each level of the volcano. Here we have we have lines. Also, we can contour lines. We can use contour lines, picture B, without any information about altitude. Also, we can describe this volcano using a shape of it. That is, in this case, a contour line for 140 meters. This is a closed polygon, as if we cut the volcano in this altitude. Also, we can cut a bit higher, and we get a polygon with hole, image D. That is, it depends on the purpose, which spatial data model you use to describe a spatial object. Point, line, polygon, or maybe image data. Besides the spatial data models, GIS data include attribute and metadata. Spatial data, that is coordinates. Attribute data are non-spatial characteristics that are connected by tables to points, lines, events on lines, and polygons. That is, for each location you visited, for example, you are doing some shopping, and for each location, for each shop you visited, you can save information about money you spent in this area. So this will, the money amount you spent will be the attribute data. Also, the important part of GIS data is metadata, information about scale, accuracy, projection or datum, data source, and manipulation, how to acquire data.
Excuse me. So attribute, it's some data which is not spatial, but is connected with objects on the map.
Yeah, connected by tables to points, to lines, and so on. Now we are going to switch to QGIS. I really don't know what to expect with my internet and with Zoom. Now I'm going to run QGIS, and I want to show you some basic steps to work with this software. Okay. Just a sec. Can you see my screen, my full screen?
Yes, we can.
QGIS is running, is going to be running. This is the window of GIS, of QGIS. This is an open source software. You can download it, and you can find the link in LMS in announcements announcement section. We are going to start from the new project. The files of QGIS are projects. In menu, you can see project, edit, view, layer, and so on sections. Let's start from project. Let's start a new project. This is an empty project, no map, no spatial data in here right now. We can add our data using this browser section. If you do not have any browser window, you can just click, you can right click and choose browser panel. Then I add some geodata. I'm going to start from continents. I just drag and drop.
Excuse me. Can you actually send us these files so we can also work in QGIS with you right now?
Okay. I'm going to stop sharing to do it a bit quicker. Just this. Before sending the files, let me share this thing. The main type of files for GIS systems are shape files, the so-called shape files. But it's not the only file with SHP extension. Can you see this? SHP, that is shapefile. It's not enough to draw a map. You will have the set of many files, the set of several files with different extensions. Some types I think are familiar to you: XML file, DBF file, that is database file, and some of files must be new. For example, something about some information about projection. So when you are asked to download the shape files, you need not only one file, you need a bunch of files. So I'm going to zip this and upload to, or maybe I will send a link to download. Okay, just a second. I'm sending a link to download in chat. Can you see this?
Yes, we can.
Please download this and unpacked. Now I'm sharing my screen with QGIS. We have a new empty project. In order to draw a map, we can just drag and drop the so-called SHP file, shape file, extension SHP, just drag and drop to QGIS window, and we have this map, the world map. Or another way to get this, just drag and drop from the browser panel. We have world continents. You can use your mouse wheel and you can get closer to different parts of the world. This is a polygon data model. This is a polygon shape file. And when we get closer to its edges, we can see vertices of the polygon. So there are lines, and we have all the continents in this map, and we can move the map. Let's have a look at the attribute table, at the attributes of this map.
Excuse me.
Okay.
Is it okay that my map is not red but violet?
Okay. Violet,
Okay.
green, it's okay.
Okay.
Because the first color is usually randomly chosen by QGIS, but I will show you how to change colors, how to color the map. Right-click, open attribute table, или так, открыть таблицу атрибутов, наверное, если у вас русская версия установлена. Open attribute table, and we get some table with data on the continents. Features, то есть свой в карту. And this layer consists of 8 objects. We can have a look at each object separately. For example, if I choose Europe, just click on the first line, and I get the Europe, and I get this object highlighted in yellow.
How to highlight it?
Just click on the table.
Okay.
Also, you can do like this. Like this. You can find 5 variables for each object ID, 6 variables. Object ID. The second variable is continent, then something SQMI, maybe square meters, then SQKM, squared kilometers, length of its shape, and the area for each continent. So, what to do next?
Excuse me, and what is the shape? It's some sort of parameter? What?
For example, Europe. You can see several polygons. Europe itself and several islands, okay? The length of its shape is the perimeter of all the polygons including in this line.
Okay, it is clear, but as for shape area?
Shape area, the area of all the polygons included in Europe continent, according to this map.
So it's total area.
Yeah,
okay.
Exactly. The total area of this object. I don't have much information about measurements, but we can have a look at properties of this layer. Right-click, Properties, правой кнопкой свойства, наверное. Information from provider. Some information about geometry, polygon, that is a polygon, and multi-polygon. Multi-polygon means that some objects consist of several polygons that are not connected with each other. For example, we see that Europe consists of itself and several isolated islands. This is multi-polygon object. A coordinate reference system, EPSG, or World Geodetic System, 84, geographic system. Extent. This is the interval for longitude and latitude coordinates from minus 119 to 108, from minus 180 to 180, minus 20 plus 20, minus 90 plus, not 90, but 83. Unit degrees, feature count, that is how many objects, 8, type data set. Source and UTF as data source encoding. Also, it's possible to set a new coordinate reference system. The next section is symbology. Here you can choose your favorite color and apply to the map. For example, let's choose this thing. Okay. Apply. In my map, one of the continents is still yellow. I think this is because in my attribute table something is chosen. Yes. We can either invert selection, that is select or deselect all the features. So we can color the map using symbology thing. Also, we can use, now we all use single symbol один symbol. Also, we can choose categorize or graduated or rule-based or inverted polygons or something else to color them. Let's try. Categorize. We need to choose a variable, for example, object ID, color ramp, random colors, apply. Oh, oops, sorry, no categories. Why? Ah, okay. This I missed one step to do this. When you choose the value and choose a color ramp, цветовая схема, then you should classify. Just click classify and you can see the different colors you have chosen. For example, like this, classify, apply, then get different colors. Also, we can color the map depending on values of some variable. For example, area. Now we apply graduated symbology. Градуированная шкала будет в зависимости от переменной площадь. Color ramp. Цветовая схема у меня будет, ну пусть это. Then I should choose classes. Насколько сколько классов будет classify, and QGIS automatically apply its mode. By default, we can use quantiles or equal interval, that is intervals from the minimum value to maximum value, 42 and 6,000. Let's apply different things. Then we should classify, or we can, for example, choose lower, a bit smaller cases, smaller classes, classify and apply. And the smaller the continent, the lighter it is depicted in this map. You can choose another color schemes, color ramps, and you get another maps. То есть можно в зависимости от выбранной цветовой схемы указать получить новую карту. Можно число указать побольше, тогда раскраска будет с большим количеством классов. That is symbology. Also, you can apply a rule-based symbology, that is, show or color only those objects that satisfy to a certain rule. You can, for example, edit this rule, the current rule. You can apply some inequality or equation and so on. Let's jump to the previous one, graduated symbology, and I leave it now. Labels. For now, we don't have any labels in our map. No labels. We can choose, for example, single labels. Of course, we're going to label using continent names. Just apply this. Oops, sorry. Oh, symbology. I'm sorry. I should do it again. Why? Not too bright. Labels. Now we have labels for each continent, single labels. We can apply different fonts, different formatting, and so on. Shadows, background, placement, around centroid, offset from centroid, horizontal, and so on.
And could you please repeat how to name those continents, not by numbers, but by...
Okay. Mhm. Labels, volume, continent, not object ID. Otherwise, we get their numbers. You choose continent. Can choose underlined font. You can change font color.
Is it okay that when we look at the map very closely, it doesn't show labels?
It's okay, depend on the settings. Let me check the section labels. Maybe it's rendering part. Here in labels section, you have subsection rendering. You can choose scale dependent visibility or pixel size based visibility. For example, if labels in a large scale, you cannot see labels because this usually depends on many things on the map. Okay, we can try to tick this one, show all labels for this layer, including colliding labels, and apply. No, I cannot see Asia. Okay. Also, you can choose settings for each for each multi-part features. For example, oops. Right. If you need to show that each island corresponds to the certain continent, you can choose this this option. Label every part of multi-part features.
However, it's not appropriate there
Yeah.
at all.
We can see that there are so many islands surrounding each continent that this option will just will just add the total mass to the map. So should just avoid ticking this. Так, вопрос в чате. Какие-нибудь книжки или курсы со всем функционалом? Обязательно будут ссылки и даже ссылки на YouTube-видео. Я понимаю, что разобраться с программой, которая совершенно не такая, как Word, Excel, Stata или то, что вы раньше использовали, это непросто. Поэтому, да, обязательно будут. Okay, now we are just using now we are just looking at the map, at the continents, and we are getting familiar with the QGIS panels, properties, and so on. When you move your mouse, you can see that coordinates changes, so you can follow mouse position. Also, you can change magnifier in here. In the case when you move your map, enlarge it, or even lose it, don't worry. You can go to the View panel. Если карту вдруг потеряли, you can go to View или Вид and zoom full. Или это может называться полный extent. Zoom full, and you'll get your map in your screen. We live in Russia, and you can have a look at this map and find that the Far East is located in this part and in this part. So this projection is not good for Russia because when we focus only in Europe and in Asia, we have very weird map. If you don't need to show all the continents, you can choose the instrument filter. Допустим, нам нужно показывать не все эти объекты. Идем правой кнопкой, выбираем фильтр, filter, continent, fields, continent. Да, поля — это переменные в таблице атрибутов. Здесь они в GIS-программах называются поля или fields. Continent. I want to have a look all the values of this variable. All. Okay. Then I need to build a query, составить запрос, continent, double click, is equal to Europe or continent is equal to Asia. То есть я хочу оставить два материка, два объекта, для которых переменная континент принимает значение либо Европа, либо Азия. Then I test this. It's okay. There were two rows. Okay. So only those objects with a given condition are displayed now. And we can see that Europe and Asia have are mainly located in this part of the map, and the Far East, the tail of this, is here.
Excuse me, could you please one more time show how to arrange by colors? No. Arrange continents by colors by maybe
Okay.
their size. One more time.
Okay. Properties. Labels. Not labels, symbology. Graduated symbols. If you are going to color them depending on values of something. For example, shape area or shape length or another variables. You can choose it.
Mm-hmm.
Then you can choose color ramp, цветовая схема. By the way, you can create your own color ramp, or you can choose several standard. You can choose from several standard color ramps. For example, I'm going to use black and white color ramp scheme.
On my screen, it doesn't show the list of variables. It's empty.
Did you choose value shape area, for example?
Yes. I have all the same, but the list of values and symbols.
List of values.
You can press classify and you'll get all of it.
Classify. Classes.
Okay.
Apply. Does it work now?
I believe I will have to look on it at home.
Did you choose graduated? Graduated.
Yes.
Then numerical value, variable, shape, object, square
Yes.
meters, square kilometers, something from this. Then color ramp. Mode, equal count or equal interval or natural breaks, something from this. For example, equal interval, number of classes, classify, then apply.
Yeah. Now it works.
Okay, great.
Okay, thank you.
Okay, now you can color your continents. you can hide some objects using filter option. Then I'm going to add another layer. Let me prepare for you to download it. I will stop sharing my screen and I'm going to send another file for you. Just a sec.
We are waiting for your link, right?
Yeah.
Okay.
Sorry, I had some troubles. You can download the next dataset using the link from the chat. The second data set is a sample from Russian cities, XY cities sample. This is the shapefile name. You can drag and drop. And you get a set of points on the map. Let's have a look at properties of this layer. Information. Coordinate reference system is geographic. World Geographic System 84. Extent, that is the minimum and maximum values for longitude and latitude. And there are 45 objects, 45 features. This is a sample from a data set on Russian cities. Let's...
Excuse me, can I ask a question?
Okay.
Yeah, so for example, we have two different pieces of data and they are in different CRS formats. So if we drag two different pieces of data in QGIS and it's in different formats, will it adjust to one certain type of data? Or
No.
you do it manually?
That's a very good question. Thank you. In QGIS, you can have many different layers. Now we have two layers. The first one is a multi-polygon layer with continents, world continents. And the second one is a point data layer with a sample of Russian cities. Please have a look at this option. You can rearrange them. You can change their order. And in this situation, in the current situation, the continents layer covers the point layer. Мы сейчас не видим точки с городами, потому что континенты их перекрыли, они сверху. In order to make it properly, you can just drag and drop to rearrange their order. Когда у вас будет больше слоев, там нужно будет регулировать либо прозрачность, либо перекрытие, что тоже будет важно. Кроме этого, вот тут галочки есть. You can change visibility, you can switch on or switch off the layers.
А вот немного другой в этом плане вопрос, но вот у нас есть CRS-форматы. Как я понимаю, вот вы сказали, их там только в одном QGIS под 3000. И как я понимаю, если у нас есть два файла с разными QRS-форматами, то у нас будет немного позиции отличаться, чем на самом деле. К примеру, вот там два разных формата на одном формате.
Координатная система вы имеете в виду?
Да, и вот там автоматически видоизменяется под какой-то единый формат, если мы в двух разных форматах загружаем эти два лейера.
По умолчанию для первого слоя какая координатная система была, для всех остальных такая же будет. То есть первый слой, он как хозяин забивает координатную систему, и все остальные принимают такую же координатную систему. Но их проекции можно менять, да. Переход к координатной системе, да, возможен. You can change your coordinate system for the whole project, not only for one layer, using project and its properties. Project properties. Here you can see if there is any information about metadata, or you can add some metadata about you. You are as an author of this project. You can type yourself. You can type your name, creation date, language, if you want to indicate it, keywords, contact information, and so on. And also you can have a look at the coordinate reference system. You can use predefined coordinate reference systems, and you can see the part of the map which are recommended for this coordinate system. Вот этим красным показана та часть карты, для которой рекомендуется использование той или иной проекции, той или иной системы координат. Например, вот это. Если вся карта выделена, то подходит для всего. Вот тут я выбрала что-то произвольное и показывает только малый кусочек, для которой эта координатная система хороша, для отображения какого региона больше всего подходит. Как мы говорили, что при переходе от геоида, от глобуса к плоской карте у нас все равно происходит искажение, и в зависимости от того, какой регион вам надо показать, есть специальные проекции. Для России мы будем пользоваться одной координатной системой и соответствующей проекцией, а для отображения, например, Австралии, Африки, Штатов, США, мы будем пользоваться другими проекциями. Это тоже будет так. Ну, пока просто оставим так же. How to save the project? This is an important thing. Just use project, save. Okay, I will name it intro, introductory project, just save. And I want to show you that this intro file is a very light file, only even less than 10 kilobytes. How that's possible? Because you must remember that you have downloaded Russian cities sample and continent sample, several megabytes, but the project itself is very small. Project itself does not contain those shape files. It contains links to those shape files. То есть, когда вы сохраняете проект и хотите, например, потом переслать кому-то вот этот проект, вы пересылаете его, но эти shape-файлы, они не входят внутрь проекта. Внутри проекта содержится информация, где лежат вот эти слои. Поэтому переместили, например, вот этот файл проекта куда-то, И при новом открытии у вас может появиться сообщение о том, что потеряны связи со слоями. Давайте я это проделаю сейчас. Так. Я сохранила и закрываю проект. Потом я перемещу проект, например, в другое место. Вот файл intro QGIS project файл. Ну, какой-нибудь просто произвольный.
By the way, we can't see your screen now.
Yeah. Sorry. I'm sharing my screen. I just move the project file to another folder. I move it. Okay. Then I'm going to open this project file with QGIS. And I have a warning message that the project file cannot find a source for 2 layers. But I can fix it by clicking each row, each line, and I click Browse. I want to fix it. World continents, geodata, world continents SHP file. Be careful, you need to find and click SHP file as the main file for the shapefile. Okay. Then the second layer, a sample of Russian cities, XY city sample SHP. I can browse it. Apply changes. Oops, this is not that file, sorry. I will add a new one. I just remove that layer and add the same layer as you have in your projects. Okay. After moving this, you can see that I lost the coloring, and I have lost some information because maybe I just add. I may have added different shape files. I have only two. This is not that layer. Yeah, right. This is not that layer. This one. Yeah. I just mixed up the layers and shape files. So, okay, moving a GIS project file is not a good idea. So now you can add names to cities. Let's have a look at properties, the point layer, XY cities sample layer, symbology, single symbol, labels, no label, but we can add their names if we have it. We have their names. In the attribute table, there are city ID, city name in Russian. So let's add this. Why? When we change the map scale, when we get closer to some observations or move the map, and after that we get less names than we expect to. It's normal because using this size of the font, we cannot place all the names. Also, we can have a look at the file properties at the attribute table and find the information about their region, their federal district, and we can color the cities depending, for example, their federal districts.
Excuse me, where we can find this table?
Attribute table. You choose this layer, cities, then right click. Open attribute table.
I see.
And you find the number of features, number of observations, and all the fields in this attribute table, even latitude and longitude.
And so I can mark them, paint them in another color as I could with continents, yes?
Yeah. Let's choose properties. Properties, symbology. Instead of single symbol, I choose graduated or categorized. I think in this case, when we are going to use federal districts, we can do both cases. Okay, federal code. Let's choose random colors. classify, then apply. Now our cities are colored depending on their federal districts. Also, when you color the layers, you can choose transparency. For example, I don't like the color of continents in the current version of my map, so I can go to properties of this layer. Symbology, okay, color. Let's choose, for example, this one. This, okay, apply. Then you can apply opacity. Прозрачность. Для каждого слоя раскраску можно регулировать. Прозрачность я поставила для слоя с континентами. Ну, окей, пусть будет около 30. Применить. Для чего еще может понадобиться прозрачность? Например, вот для таких случаев. Когда меняете порядок слоев, и в случае, если, скажем так, переместилось, в случае, если какой-то слой с полигонами перекрывает другой, но вы хотите часть информации все-таки делать доступным, и для того и другого слоя, вы можете регулировать прозрачность, и тогда вот сейчас, например, у меня континенты перекрывают города, но тем не менее информация о городах видна. Это из-за выбора прозрачности слоя. Окей. Так, вопрос из чата. Так, до ара, я думаю, мы пока... До ара мы дойдем через неделю. На следующей неделе еще QGIS будет. В аре мы с вами будем работать независимо от QGIS. Курс у нас довольно короткий, и из-за полного онлайна еще приходится учитывать особенности. Поэтому моя цель — дать вам основу работы в QGIS, показать возможности, затем показать вам, как в аре работать с пространственными данными, те же самые карты рисовать, но AR будет использоваться не только для рисования карт, но и для пространственного анализа и для получения воспроизводимых результатов, потому что там мы будем писать код, и его можно будет запускать и получать воспроизводимые результаты, не последовательностью кнопок, как в QGIS. Так, время у нас неумолимо бежит, заканчивается время, отведенное на занятие. Я прошу прощения за технические проблемы, с которыми сегодня столкнулись. Понимаю, что вам потребуется какое-то время, чтобы освоить QGIS. Со следующей недели мы будем его активно использовать, поэтому дома или если вы предпочтете в каких-то компьютерных классах работать, а на Кантемировской в каких-то классах QGIS установлен, посмотрите, пожалуйста, на сайте, в каких аудиториях это есть, если вы планируете самостоятельно работать. Если у кого-то совершенно не запускается или не устанавливается QGIS, пожалуйста, напишите об этом до пятницы. Мы попробуем индивидуально там устранить эти проблемы. Я вам отправлю ссылки на тьюториал по освоению этой программы. Также отправлю ссылки на ютубовские курсы, чтобы вы могли просто вот повторяя привыкнуть к этой программе. Есть ли вопросы? Do you have any question for now? Is everything clear or nothing is clear?
So you will send us some materials to explore.
Yeah. You'll get links to YouTube courses. You'll get QGIS tutorials on the official site of QGIS. Also, I'll upload the slides to LMS. More questions?
Everything is clear. Thank you.
Okay, great. Okay, see you next Monday, and off you go.
Okay, thank you. Goodbye.
Goodbye.
Thank you. Goodbye.
Thank you.